So some of you may or may not have ever done this. And there's lots of ways to attack quadratics. And so basically 5, 3, 5, 4, and 5, 5, if that's something that really does interest you, then I would definitely encourage you to take college algebra next. Don't go back to Math 100, right? This course is equivalent to Math 100. So if you want to go algebra track, just go right into Math 122. But that's where you really kind of dive into the rest of this chapter. So again, we're just going to scratch the surface on this. There's a lot of ways to solve these problems. So if you have a method that works for you because you've done this before and you want to use that, then by means use it, right? Because there's more than one way to solve these problems. I'm going to kind of show you the ways that the book kind of goes into. Again, I've given you a little more information in the book because I teach algebra as well. So I added a few key pieces, but the Hawks will show you that there's not really as much to this. If we have time, I'll try to go into Hawks, but if not, I did put on the video. When you graph the quadratic in Hawks, you got to put in the vertex first, right? And then you got to drag the points around to the other things. And that'll make more sense here in a second. So what is a quadratic, right? A quadratic is set up as having an x squared, right? So, and you may have a middle term of x, or you may not. It's not required. Because if there is no middle term of x, then the b value is just 0, right? And then you may or may not have a constant. The key to having a quadratic is having an x squared. If you do not have an x squared, you do not have a quadratic. The rest of the equation could be 0 and it will still work. And then all quadratics form the graph as what we call a parabola, which is that lovely bell curve, right? And the trick is, if A is positive, my parabola goes up. If A is negative, so I have a negative A, then my parabola goes down, right? And this is key when you're graphing it, because it will help make sure that everything is going the right way, right? So that's a neat little trick. You know, when you go to graph this, if your A is positive and your graph is going down, then there is an issue somewhere, right? And if the A and vice versa, right? And so just real quick, I think I've already skipped over it though, so I don't know if I can go back to it. I did. Exit without saving. So what problem I'm just talking about, I'm not going to do it right now. I just want to show you so you can go to it. No, that's a line. There it is. This is the one. Graph, they're probably using it. I don't know why they say the 5-step method, because you only need to plot 3 points. So this is how I'm going to talk to you to get the 3 points. But when you go to graph this, the vertex is where it turns. So find that first and put that wherever it goes, and then you can drag the other points to make the shape of it, right? And because they are proportionally related, you notice I only have to move one of them, and it automatically puts the other one where it goes. So the key is putting the vertex where it goes first, then put in the next one, and then your answer is done, right? And then this answer I already know is wrong, because notice my x squared is positive. So this thing, and I'm trying to move them now. Come on, got too close to the bottom. I don't know what I hit here. There we go. This one should be going up because it's positive. But we'll get into how to graph this. But this is the problem you're looking for, where it says the 5-step method. And again, I don't know why Hawk says a 5-step method. I didn't use the tutor to help me solve this. You only have to plot 3 points. So to me, that's the 3-step method, but this is neither here or there. So some examples of quadratics in everyday life: a rocket trajectory, light, the old fashioned. I don't know if the new headlights are. I don't think they are, because they're all halogen and all these crazy things. Not halogen, LED. But old headlights in cars, the little metal thing, I don't know what it's called because I'm not a car guy, but inside the headlight, the little silver piece, I think it's aluminum, is parabola shaped. because parabolas have this unique ability that no matter how light comes into this, it automatically bounces back off and comes out in a perfectly straight line. And that's what's one of the cool things about parabolas. I say cool because I'm a geek, but that's what kind of parabolas do. And like I said, rocket trajectory, and stuff like that, and stuff in space. A lot of things have like this parabola shape. So this is called up here, ax squared plus bx plus c is called the quadratic equation, right? And the key is, you notice it equals 0. It always has to equal 0. I can take any equation in the world and make it equal 0 by moving everything to one side, right? So if something doesn't equal 0, you can make it equal 0. Just take everything and move it to one side, leave nothing on the right-hand side, therefore the value is 0, right? So I can make anything equal 0 by moving everything over. And that's the first step. So make it equal 0. And then put them in order of your x powers. So x squared first, followed by x, followed by your constant without an x. And the reason you want to do that is because every value has a meaning, and they're called parameters. X is the variable. A, B, and C are called parameters because you must give them values. And once you give them values, you have a single quadratic equation, one graph for that system, right? And then what you do is you basically just take those values out of that formula and you put them into the quadratic formula, right? So the first thing is called a quadratic equation. This fun thing down here is called the quadratic formula, and we use that to solve. And what is this is called? These are called the roots. This is where your parabola crosses the x-axis. So very similar to a line where I had y equals mx plus b, and b was the y-intercept, where the line crossed the y-axis. These values are where x crosses the x-axis, right? And you're almost always going to get two answers. There is a chance to only get one, but that is a very, very special case. So typically just realize you're going to get two answers for x. And when you do that, they are going to give you 2 points. The first answer, I'll call it x with a subscript of 1, saying your first x value. And then the y value is 0. Notice, because that's the value that's in the y spot. And then your second x point, also y is 0. So, oops, that's a horrible look in parentheses. So if I go back to here, which I really screwed up this problem. All right, try similar since I messed up this graph so bad. There we go. So that's how you're going to do this problem. You're going to find out where the points cross the x-axis, and you're going to drop them right there on that spot. And then you're going to have to find the vertex, right? So we haven't talked about how to find that yet, but we will. But that's how you do this problem. Where these lie on the x-axis is the x1 and x2. And then we'll get here in a minute when we find the vertex, all right? So to solve this equation, you just take the numbers 8, 4, and 3. Notice 8 is A, B is 4, C is 3, and I just put those into this equation or this formula and I solve. What confuses people when they first do this problem is this whole plus minus. Your calculator does not have a plus minus, right? What that means is you need to do this equation twice. You do it once with the addition, which gives you your x1 value, and then you do it again with the subtraction, which will give you a different x value, all right? So you're going to have to do it twice, hence why I say you will almost always get two answers, because you're going to do it once with a plus, you're going to do it once with a minus, and you get the two different answers. One thing that you don't need to solve the problem that we'd like to talk about is, again, the y-intercept. To find out where this crosses the y-axis, again, you put in the values 0 for x. Well, you notice the only thing left is the c. So the c is the y-intercept. Very similar, it's like the b and y equals mx plus b was the y-intercept. The c in this case is the y-intercept. So this is the point 0, comma c, right? And the only reason it's a different letter just because b ended up becoming the middle thing, right? So don't try not to stress too much on that piece, why the letters changed. It has changed because we added more variables, right? And then finally, to find our vertex. The vertex is this very special formula where the x, the value that goes in the x spot is negative b over 2a. It is the first part of the quadratic formula. To find the y value, you take that number and put it into the quadratic equation and solve it, and then you will get the y value. So 4 different things here. I get 2 x points, I get the y-intercept, and I get the vertex. And the vertex is the point where the quadratic turns, all right? So now we've explained the concepts, let's actually solve a problem, right? So if I have the equation, and I'll write it out so we can see me doing a step-by-step too. If I have 2x squared plus 8x equals negative 6. Remember, the first thing we need to do is get this thing to equal 0. So what I'm going to do is I am going to add 6 to both sides. So then I get 2x squared plus 8x plus 6 equals 0. Like I said, to get anything to equal 0, you just move everything over, right? Now I can do the quadratic formula. So my first x value, and what I'll do is I'll do a little x1. And all a subscript means is just to identify that this is one of my solutions, right? So x1 just means the first x solution. So x1 will equal negative b. So remember, I'll put the letters below, and this guy is a, this guy is b, and this is c, right? So when I go to put this into my quadratic formula, I have negative b, so this becomes negative 8. And I'm going to do the addition one first, so plus the square root of b squared, so that becomes 8 squared minus 4. I'm going to put everything in parentheses just to save my handwriting. Times a, which is 2, so negative 4 times 2. And then times c. C in this case is 6. And that's all under the square root. And then I take all of that and I divide it by 2 times a, which is also 2 in this case. So all I did was take this formula up here and I substituted in what b was, what a was, and what c was, right? Now, the next process is completely up to you. Most of you are going to solve this in steps because that's how you feel comfortable, right? However, you can just put this into a calculator all at once. If you want to put this into a calculator all at once, I add in a parentheses here and a parentheses here to let my calculator know that all of that is in the numerator. And then I put a parentheses down here and a parentheses down here to let my calculator know all of that is in the denominator. Now, if you have a calculator handy, I would highly encourage you to do this with me. That way, if you don't get the answer I do, I can try to walk through with you what you might have typed in wrong. I am going to put mine in all at once. So I will talk when I'm doing, as I'm doing this, but I'm literally just going to type in exactly what you see on the screen. So I got my calculator. I'm going to do parentheses, not subtraction. Find your negative key. So negative 8 plus, find your square root key. 8 squared minus 4 times 2 times 6. You may have to push on your little arrows in the corner of your calculator to get out of the inside of the square root. So if you're looking at your calculator and you got a flashing thing under the square root, make sure you push the little arrow key on your calculator so you're not under the square root no more. put in that parenthesis to close out your numerator. Then I'm going to hit divide, parentheses, 2 times 2, which is 4, but I'm still going to write it all out. Close that parentheses, and if I do that, I get the answer of -1. So my first x value, oh, I wrote 1 when I meant to write -1, sorry. Got -1. How do we do? Do we all get -1 as well? I see a couple people still working, so I'll pause. Now, depending on your calculator, you might be able to just scroll up and change this plus to a minus. My calculator that I got here in front of me does not let me do that, so I have to type the whole thing in again. But I don't have one of the two I recommended. I'm pretty sure. I don't know if the Texas can. I know the Casio can for sure. That's why I love my Casio. Casio, you can just push the up arrow key. You can put the cursor over this plus and turn it to a subtraction, and then hit enter, and then the second problem is done for you that quickly. But if your calculator does not let you do that, then again, you're just going to redo the whole problem again. But instead of doing plus, you're going to subtract the square root. All over 2 times 2. Oops. Oh, I put x for times. And again, if you're going to put all this once in your calculator, then parentheses the top, parentheses the bottom. I'll clean this up, put it, yeah. 2. All right, so the only difference was, and I'll highlight it, one time it was a subtraction, and one time it is a plus. So if we redo this problem again, and I have to retype all mine because it doesn't, the scroll thing does not work on mine. So -8 minus square root 8 squared minus 4 times 2 times 6. Close parentheses divided by 2 times 2 is, I'm only put 4 in this time. So this guy, I get the answer of -3. So when I go to graph this thing, my first point is going to be -3, 0. And my other point is going to be -1, 0. So that's a little tedious. I'm going to say it's not. To find the y-intercept, that is probably the easiest of the things to find, because that is the value of whatever's in the C spot, because I put in 0 for x. So 2 times 0 is 0. I put 0 in for x. 8 times 0 is still 0. So if I put in 0 for everything, then the only thing left is the 6. So my y-intercept is the point 0, 6. So I now have 3 points to graph this thing. However, I need the vertex. I need to know where this thing turns, right? So to find the vertex, and this is where it gets a little tricky because we have x's everywhere. So instead of using the x, to find the first value, we're going to use the formula -b over 2a, right? So to find the first value, that is -b over 2a. So I'll leave myself some space. So remember, b was 8, so that is -8 over 2a, so that's 2 times 2 again, which gives me -8 divided by 4, which just gives me -2. So my x coordinate, instead of calling it what x value, I'm going to call my x coordinate. My x coordinate for my vertex is -2. Now, what I have to do to find the y coordinate is I take that answer and I put it into the function, right? So that's why it has this f in front of it. So what I do here to find the y coordinate is I take -2 and I put it everywhere there's an x. So to do this next piece, I'll put a big old comma here. This is going to be 8 times -2. Wait, no, not 8, sorry, 2. Dang it, I didn't scroll up enough. I go back to the function because the function is 2x squared. So I'm going to do 2 parentheses -2 squared plus 8 times -2 plus 6. I put -2 into the equation, right? So I take my calculator, clear out everything on my calculator, it's a mess. 2 times, remember when you put negative in your calculator, you have to put it in parentheses or your calculator is not going to square that negative, right? So parentheses, -2, close parentheses, squared, plus 8 times -2 plus 6 gives me an answer of -2 again. And of course, I don't have my answers here, so I'm hoping I'm doing this right. So if someone else gets a different answer, please let me know. Check my math here. 2 times, so -2 squared is 4. So 2 times 4 is 8. Yep. All right. Good. Thank you. So, oh, whoa. I got stuff in the chat now. Maybe I am doing something wrong. When I clean upon the steps, I'm fine though. How important is it to learn how to do it? No, you don't have to type in all at once. But if you do it in steps, are you getting the same answer as me? Because if not, I want to make sure maybe I did something wrong. So I'm just seeing the chats now. So you have the 30xa. I don't have that one.
I guess honestly, I haven't been doing it. I've been trying to figure out the functions on the calculator. So I haven't been doing them out the long way. But when I do it in my homework, I get it right every time if I just go ahead and follow the steps.
Okay.
It's just learning how to use the calculator is not fun.
Yes. TI-36A. Let me see which one that one is. Oh, it's that one. Okay.
You have to do everything backwards on
Yes.
it.
I hate this calculator. This is why I never recommend this one. Yes, you have to do everything backwards on this one. If you have this calculator, no Edge, I don't need coupons. If you have this calculator, you do have to do it all backwards. So you must do this in steps. I do not like this calculator because of that reason. This calculator does not let you put it in all at once. So thank you for bringing that up in the chat. TI-30X alphas, you cannot do it all at once that I've been able to find, right? Because Kim's perfectly correct. You kind of have to do it backwards. You put what's in the square root, then you hit the key. And that's why you can't do it all at once. If you have the Casio or the TI-30X IS, I think it's what it's called, those ones you can. I have the TI-36X Pro and you can do it all at once. Again, I think one of you messaged me and said they like Excel. Not to confuse more people here, but if I bring up an Excel, I can just type it in as the same thing. So I put in an equal sign, put in my parentheses. This will make sure I'm getting the right answers now. So let me go back to my problem here. Bring up my Excel. So we had -8 minus the square root function. So that's SQRT of 8 squared minus 4 times 2 times 6. Close my square root function, close my numerator, divided by 2 times 2. So I can type it all in Excel, and I thank God got -3. So you may use Excel on the tests or projects if you choose to. Again, don't have to. This is why I say just get comfortable. So if on your calculator, Kim and someone else agreed with her, and Jennifer said, I like doing it in steps. Perfectly fine. Then do them in steps. There's nothing wrong with that. My only concern with steps is the more steps that you take, the more chance that you could type something in wrong in one point, right? So that's all my only fear of steps, because I usually do it. That's why it's my fear. By typing it all in once, if I get a weird answer, I can quickly look and say, what did I do wrong here? And even in the certain calculators that let you type it all at once, you can use the scroll function and scroll back and fix that one number, like I said. So that's one benefit that you may get by doing it all once, but if your calculator don't get it, or if it is confusing you, then please do it in steps. There's nothing wrong with doing it in steps, all right? So there's, at least I know that is correct in Excel. And so do we get -2 and -2 for our vertex? I think so. Let me, again, I can always use trusty old Excel. So 2 times parentheses -2 squared plus 8 times negative, I'll put in parentheses just to make sure Excel knows that's a times, -2 plus 6. Yeah, see, Excel doesn't like it. What did I do wrong? Oh, I got double equal sign in there. That's why. There we go. And I got -2 again. So typically when we get these wrong, it's an arithmetic mistake somewhere. That's why I'm triple checking my work. And so now that we have these, so now so this is my vertex. Let me write this over here. I'll put a big V here. So now I have a total of 4 points. I have the vertex, I have my y-intercept, and I have my 2 x coordinates. So now what I can do is I can create my y-x. And the good news is you don't have to do this because Hawks has already created the graphing plane for you. But plot your vertex first. So that's down 2. And to the left 2, right? So there is my vertex of the point -2, 2. Right? My y-intercept was the point 0, +6. So 1, 2, 3, 4, 5, 6. So that is that point way up there. And then my x values was -3, 0. Oh, I'll mark them in green so you can see them. -3, 0, and -1, 0. And then as steady as a hand I can do to draw this. I know we don't like red, but I'm gonna try just so it stands out. We'll pick another color. We don't like red. So let's go, we'll go pink. Good old pink. So I start on my vertex and I try to connect the dots as best as I can. And there is my lovely pink parabola. And with my artistic skills, I'm going to still stick with the word lovely. So when you go to do this in Hawks, remember the only points you're going to have to do in Hawks is the 2 x's and the vertex. Right. And so again, when you go to graph it in Hawks, put the vertex where it goes first, then put your x's where they go next, and you should be fine. And again,
since Hawks is only asking for the 2 x's in the vertex, are we going to need to know how to solve for y for a quiz?
nope.
Okay.
All right. So a problem that was asked to do today was on page 214, number 16 in the book. And this is a tough problem. So it took me a minute to wrap my head around. There's not one like this in Hawks, but it is a good problem. So so I keep bumping my mute button. The population in thousands for Tylersville, T years after January 1st, 2020 is modeled by the quadratic function of 0.7 t squared plus 0.12 t plus 3450, 3,450. In what month and year does Tylerville's population reach twice its initial population, right? And this is word for word out of the book, and then change it in the wording, right? So how would I attack this? Well, what I would do is figure out where I'm at currently. So to find out where I'm at currently, I am going to let t equal 0, right? I'm letting t equal 0 because that's my starting point. Let's find out where my population is on January 1st, 2020, right? And since t is everything after that date, that is why I know that that is the starting point, and so therefore that has to be 0. So if I put 0 for where t is, it's very similar to finding the y-intercept, right? So I get 0.7 times 0 squared plus 12 times 0, that's a horrible looking 0, plus 3450. Well, 0 times anything is 0, so all of those end up canceling. So my population on January 1st, 2020 equals 3450. And again, that's in thousands, right? So a much bigger number, but we don't have to add all the zeros. So that's my starting population, 3450 in thousands. Now what I want to know, when will it reach twice this amount, right? So basically what does that mean is I double this. I multiply this by 2. And there's more than one way to attack this. This is how I attacked it, okay? So 3450 times 2, I want to say, I don't want to confuse people, so I'm just not going to attempt to do this in my head. Of course, I broke my calculator, so that's not helping. 3450 times 2, 6900. Okay, I was right. So then this equals 6900. So I know that is what my population wants to get to. So I'm asking myself, how long does it take to get from 3450 to 6900 if my population growth is based on this quadratic function, right? Well, that's where I want it to equal. So I take my quadratic equation, 6900 is where I want it to equal. And now I put 0.7t squared plus 12t plus 3450. And then, like I said at the beginning of this, the first thing we have to do is make this thing equal 0 again, right? So how do I do that? I subtract 6900 from both sides. So I get 0 equals 0.7t squared plus 12t minus 3450. So 3450 minus 6900 gives you minus 3450. Now, what I can do is I apply the quadratic formula. Because I got it to equal 0, I have an A, I have a B, and I have a C. All right, so I am going to cheat. It's not what I want to do. Get over here. I am going to use Excel to type it all in instead of my calculator because I just prefer Excel, but you may do it in your calculator, but I'll write out everything so you can see it. So I know A equals 0.7, B equals 12, and C equals negative 3450. So when I go to do my quadratic equation, equals parentheses, negative B, so negative 12, minus the square root of B squared, so 12 squared, minus 4 times A of 0.7 times C of negative 3450. And I'll do it in steps so if people want to see it. Yes, fix my thing. So if I do just the numerator, I end up getting negative 111.015. And then I have to divide that by parentheses, 2a, right? So 2 times a, which is 0.7. Yeah. And I get negative 79. Does negative 79 make any sense? No. So unless we're going backwards in time, makes no sense. So that answer is no good. But remember, we have to do this twice, right? We have to do it once with a subtraction and once with a plus. So here's the benefit of doing an Excel. I can just come into my Excel function, take that negative sign, delete it, put a plus sign in, and now I get a positive 62.15. Now that is positive, so that makes sense. So this is 62.15 years later. So if it is January 1st, 2020, if I add 62 years to that, I'm going to get the year 2072, right? Sorry, not 2072, 2082. Because 20 plus 62. So I get 2082, right? But now I got this whole 0.15 I got to deal with because it wants months. So 1.5368. So the best way to attack that is if I take the decimal and it's 0.15 of a year. So if I multiply that by 12, because that's how many months are in a year, I get 1.8, right? So that means I've completed the first month and I am 0.8 through the second month. Well, it doesn't ask what day it is. So I just know I haven't quite reached 2. So I haven't completed February. So then my answer should be February. I'll just type it in as numbers 2. We'll just call it 1 because it only cares about month of 2082. So February of 2082, oops, lost my OneNote. I lost my Excel. February of 2082 is when I get double my population. So now to make sure I did it correctly, let's make, hopefully the book and I agree. No, it says 2072. I do bad math. I got 2072. Maybe this one where I got it right. I type it in wrong. Let's see. Let me check all my numbers here because I say I'm 10 years off. C11 is A, C, B. Nope, I think it's a typo in the book.
The book
Someone else?
says 2010 and you wrote 2020. I believe that's your error.
Thank you. Thank you, man. This is why no one should ever come to me for humanities tutoring. All right, so me and the book do agree. 2010. So there we go. That makes sense because 10 plus 62 is 72. So yeah, my math is correct. My grammar's wrong again. So yeah, so that should be 2072. There we go. Now we all agree. That was a good one. I had to think about it. And there's a lot of other ways if someone might have attacked it. If someone wants to share how they did it, that is completely fine as well, because that's what's so good about this class, right? Because we can use algebra or we can use other ways because we're quantitative reason. We're solving problems using math and logic. So you don't always have to solve it this way. This is how I attacked it. But that was a good problem. There is a population problem kind of in it, but it is more of asking what would the population be in 50 years? So they give you the time in the Hawks problem, if I remember correctly. I don't know if it's before or after. Yeah, so this is very similar to the problem that we just did. Oh, it's almost the exact same figures. But instead of finding out where you'll be, they tell you how many years. So January 1st of 2012 to January 1st of 2024. So 24 minus 12 is 12 years. So T is 12 in this case, and you're just putting 12 in for T and solving. So be careful when you read this problem. This is not like, this is similar to the problem we did, but the problem we just did asked us to estimate the years. The problem here in Hawks is asking you to estimate how many people will be in the town in so many years. So look at how many years the problem's asking you to do. And then now you don't have to actually do the quadratic to solve this formula. You are just putting in those years in for T and solving.
What does it mean by round your answer to the nearest person?
So when you get a decimal, we'll just round. They don't want you to have part of a person, right? So we can do this real quick. We got time. I'd rather go through this chapter slow because this is usually the top chapter that I have most questions on. So 0.7,
Yeah, I'm having a really tough time with it.
12 times 12, and it's squared, plus 6 times 12 plus 2600. Make sure I type in enough zeros because I think that's what I did wrong. I think I get this one wrong on the chapter review. Again, not reading carefully enough. I didn't type enough zeros in. So if I type this in my calculator, I get 26172.8. It's not even gonna let me show you the 0.8 because it tells me not to put it in. But my calculator, I have a 0.8 afterwards. So 0.8 is higher than 0.5. So my 72 becomes a 73. So I'll write it out so you can see why it means around. So if you type this in your calculator, I got 26172.8. So by rounding to the nearest person, I have to round up. So it becomes a 3.
Can I be a pain? Can we do it all out? Because don't you have to get P or T by itself first?
Nope, that's only when we're doing the one where we just did with, you got to find out what T is. Maybe I should say that. So, because we are in the year 2024, right? And we're starting in the year 2012. I take 2024. I subtract 2012, which gives me 12 years. So that is what T is. There's a 12 years difference between 2024 and 2012. So then I put 12 in for that. And I put 12 in, I guess I didn't have to write the number twice, in for T. So when I go to type this into my calculator, I would put in 0.7 parentheses 12 squared plus 6 times 12 plus 26,000. Make sure I have enough zeros. And then you type that into your calculator and you should get 26,172.8.
I got 26,082.08.
Well, I know I got the right answer, so let me make sure I wrote this down correctly in front of you. That might be my first problem. 0.7 plus times 12 squared plus 6 times 12 plus 26. Oh, I do not like this calculator. Did you do it all at once or did you do it in pieces?
I did it all at once. I have the Casio.
Okay, so you put in 0.7 times 12 squared plus 6 times 12 plus 26,000. You got what?
You know what? I think I put my squared into the parentheses with the 12 instead of outside of it.
That should not matter, but you can try it to see. And sometimes
I
the
get 26,082.08.
26,082. Oh, so it was there. 26,082.8. Do me a favor, because I can't remember. I don't have my Casio in front of me. Did you put a times in here or would you just put parentheses?
I just put in parentheses.
Try putting the times in. Some calculators know parentheses mean times, some do not. So do 0.7 times 12 squared plus 6 times 12 plus 26,000.
$26,082.08.
What the heck?
I don't know what I'm doing. Is anybody else getting this?
And of course I did not.
I'm putting in 0.07.
Oh, okay.
0.7.
Yes.
Okay.
I was like, I didn't bring my Casio today. And I meant to too, because I told my statistics class I was going to have that specific calculator. And I forgot it. Okay, good. And I
Yep,
don't.
that's what I was doing. Okay.
Perfect. And that happens. You'll see in my videos, I'll make mistakes. I'm like, what? I know I'm right. And then it's because I just typed something in my calculator wrong. So that happens a lot as well. All right, so I gotta clear my pen. I'm like, why is my drawings look worse than normal? So a lot to quadratics, right? How are we doing on time? All right, I'm gonna go over this, and then I think what I'm gonna do is after spring break, I'm gonna refresh this. All right, because one, we have about 20 minutes, but for most of you, you've probably never seen this. So I'm gonna cover it. We'll practice it, and then after spring break, I'll kind of do a quick recap to see if anyone has any questions, right? Because 5.4 and 5.5 have this cool relationship where they're like brother and sister. They are related, and once I get the pattern here, I can jump between the two. So I'll talk a bit here about what these things are. We'll play around with them until 4, because that's when class ends. And then again, after spring break, I'll recap anything on 5 like we did today. If anybody has questions, spend about half hour of it, then if we need it, and then we'll go into probability because I don't want to rush it. So something that has exponential growth, and you hear this a lot of people say that's happening exponentially, right? And it may or may not be, but I think it's just a term that gets thrown around a lot. I've heard it a lot during COVID times here where they say the growth's exponential. I don't know if the growth's been actually exponential, but what makes something exponential, right? What makes something exponential is now I write my equation. I still have my favorite variable y is to be and what it equals. And it equals some parameter, and we use the letter b, but you can pick any letter you like. And what happens now is the variable is in the exponent. That's what makes something exponential. The variable is now the exponent. So everything we've done now, the variable has been one of the parameters. In fact, not parameters, that's not the right term. It's basically been the base. There we go. It's been the base. So it's either been linear in the linear base or it's been in the quadratic base, but it has always been the base, right? Now my exponent is the variable, right? And so that's where it gets interesting. And so for something to be exponential, it has some rules, right? B has to be greater than 0. In other words, B has to be positive, right? B cannot be 0 because 0 raised to any power is just 0. So it doesn't move. So that's why it can't be 0. And B can be negative. However, if B is negative, it's just not exponential, okay? So I don't want you to think it can never be negative. It can be, but if it is, it's just not exponential. It's some other type of function, right? So for something to be exponential, the b, the base, has to be positive. Can't be 0. And it also can't be 1. And the reason it can't be 1, because if b is 1, 1 to any power is still 1, and now we're back to just a line. So again, if b is 1, if y equals b, y equals 1, that is just a line, right? So that's why it can't be 1, because it won't be exponential. X can be any real number. So back to domain, like we were talking about at the beginning of the class, right? X can be anything. X can be 0. X can be 1. X can be a fraction. X can be a decimal. X can even be negative. X can be any real number. Range, what can Y be? Y is always going to be positive. And the reason Y is always going to be positive is because B has to always be positive, right? So if I have something that's exponential, I know my range and I know my domain. And basically what the x-axis becomes what we call the asymptote. And all an asymptote is means that I will never cross it, right? In which this means I can never get a value of 0, right? Because remember, if I touch the y-axis, if I touch the x-axis, the y value is 0, right? And since I can never touch the x-axis, I can never get a y value of 0. And then I don't know if I told you this class or another class, I took a class in grad school, when is 0 really 0? And this is a perfect example. It will get really close to where it looks like it is actually touching the x-axis, but it's not. It will never be 0. It'll get really, really small, but it'll never be 0. So that's some of the cool functions of what an exponential is, right? And so what I have here is I've got y equals 2x, right? And so if I use the table method, I can pick some x values, so -3, -2, -1, 0, 1, 2, and 3. And then I take those and put them in for x, and I solve for y. So this first one, y equals 2. And if I put in -3, you got to remember your rules of exponents, or check your calculator. And hopefully your calculator can do exponents. When I have a negative exponent, it means it flips. So this becomes 1/2 to the third power. So negative exponents just mean I flip the base. It does not make it negative, because remember, our answer cannot be negative. So I just flip the base. So I would get 1/2 cubed. Well, 2 cubed is 8. So I get the answer of 1/8. So this is a good time to test to see if your calculator can do negative exponents. Some can, some cannot. So I don't even know if mine can. I'm going to test it right now. So I want to put in 2. Use my exponent key and put in -3, and my calculator actually gives me 1/8. All right, yours may give you 1/8, or it may give you 0.125, which is the decimal form of 1/8. If you get an error, that means your calculator cannot do negative exponents. And again, if we do it in Excel, equals, what was my base? 2 raised to the -3 power. Oops. Gotta forget to put in my parentheses, -3 power, and Excel can do it. All right, so, or if you want to do it by hand, just remember negative means flip it, and then you can go to your calculator and do 2 to the third power. Oh, good. So one good positive, I guess, came to the TI-30XA, that it can do it, but it is going backwards. Good. So that's the table method. It's just like we did in 5.1. I have to check my things. Now, if I graph this, and I believe if it's going to cooperate with me, if not, I'll do it in Excel. I should be able to just do this if I go into math mode. So if I highlight this, escape, just so you can see what the graph looks like. And again, you don't have to graph these. If I go to math, I can select action and I graph it. And that's what the graph looks like. So you can see when it graphs it even on this, and depending on where your screen is, I'll move this a little bit, because I think when I get near the edge, it's hard to see from some. It looks like it's touching the x-axis, but remember, it's not. It's getting extremely, extremely close. So you can see how quickly this comes down. And that's where the term things grow exponentially. You see how fast this thing increases, right? I pass 0 and this thing skyrockets. And that's kind of how exponential does look. But notice it never comes down. So that's why when I listen to the news and they tell me COVID's exponential, that's not a good sign, because if COVID was exponential, we're all going to die, because there is no downward turn. We need that downward turn, right? So COVID is not exponential. It did grow dramatically fast, but it is got a curve to it. So everything they keep talking about, this curve, we're going to get to that in chapter 8. Right? We want this thing to turn into what we call a bell shape, a normal curve. And that's what we'll cover in chapter 8, right? But this is what it means to grow exponentially. It grows quickly and it continues to go up. It is never going to turn, right? It has one turn, and that's the one you see right there. And what's interesting is if I graph this other one, so I took 1/2 and I just made it, I took 2 and made it 1/2, right? So if I now highlight him and go to math mode and I graph him, they just swapped. Remember, so if you remember the other graph, as X was positive, as X went to the right, it climbed quickly, right? Notice now, as X goes to the right, it decreases quickly. Again, it can never be negative. So you're going to have 2 or 1 things happen. You're either going to have it increase exponentially, or you're going to have something decrease exponentially. So something that decreases exponentially is radioactive half-life, right? So in biological and science, when you hear about half-life in radiation decay or half-life in any kind of decay function, that's what it's saying. It cuts itself in half. That's why it's called half-life. And it is exponential and it drops like this. So it will drop quickly, but it will get to a point where it will slowly stop changing, right? So there is that changing point. That is something that follows exponential, right? And again, you can graph these is just pick a couple X's, put them into it, and just put them into the equation. And I think you do a couple of those. What is interesting is there is a E key on your calculator. So a lot of people think that E key is the only exponential. E is exponential, right? But it is a very specific exponential. The E key on your calculator is when E equals B, right? Because remember, B is our base. And so we already saw that we just did base 2 and it worked. So there is lots of different exponential functions. Exponential just means that the variable is in the X spot, in the exponent spot, right? The E key on your calculator is just a very specific value. So I like to do this with everybody to make sure they know how to get it in their calculator. So find your E key on your calculator and then raise it to the power of 1. And if you do that, you should get the number 2.718. Ooh, I got a typo. 2718, delete 281828. And it keeps going. So I should have put dots in there. Dot, dot, dot. It's kind of like pi in the fact that it goes on forever. And it does look like it repeats, but it doesn't. After a while, the numbers do change a little bit. So it is an irrational number because it goes on forever and it doesn't have a repeating pattern. So that is e to the 1 power. And again, I can put in any number for X. I told you to put in 1, so you get 2.718, but you could put in any value, right? And you will also get a graph that's exponential. So if I create this so we can graph it real quick, y equal, it's going to look a lot like the other one because you can see 2.7 to 2 is not a big difference, but y equals e to the x. I don't know, because I can't go into math mode unless I open it up, I think, but we'll see if it'll let me. Oh, it did. Graph in 2 dimension. I don't know why it didn't. Oh, is it because I have a capital Y, really? There, no, there it went. So you can see it looks very similar to one we just did before because 2.7 is not a big difference from 2, right? But that is kind of, and what it is, what makes exponential interesting is it crosses right at 1, right? But again, it's just one of the special cases. So not a big deal. What I really want you to take from the E is where it is on your calculator and how you type it in. So we got about 5 minutes left. So I think what we go into in our book, all right, if you take 122, we dive into the theory behind all of this and stuff, but we don't get to that in our class. Again, we're just scratching the surface in quantitative reasoning versus college algebra. You really dive into what is exponential. And if you take pre-calc, then you really get into how these things benefit you. But for us, what we want to know is how they're used in the real world, right? That's the base, that's the purpose of our course. So there's a couple functions out there that are exponential. We have one, it's called percent increase, is followed with this equation of f of x equals a plus in parentheses 1 plus r raised to the x. And notice b here is this weird big thing. You don't have to have a single b value to be exponential. The definition of exponential is the x, right, has to be the exponent, and b just has to be positive. Well, r is interest rate, and so since interest rate is not negative, right, therefore I'm always going to have a positive answer. So a is your starting balance, r is the rate of change, x is time intervals, and we will dive into this formula much further in chapter 9 when we get into finances, because this is the compound interest formula, right? So we will get into compound interest. So I'm not going to do a lot with this formula right now. There may be one problem in the review about percent increase, but that is a known formula that's in the real world that uses the exponential function. To do an example from the book, and then we'll stop here and we'll basically do logarithmic after break, which will give me a good review of exponential, because like I said, they're kind of like brother and sister. We'll do this problem and then call it. So a certain town has a population of had a population of 2,000 in the year 2001. If the population is increasing at a rate of 2% per year, what would the population be in 2021, right? So again, this is out of our book on page 221, example 4. So it's not one of the homework problems. So using our little formula above, right? A, no, I hate that my thing always capitalizes. A, there we go. A is equal to our starting. So that would be a population of 2,000. Our R is 2%. And then remember, we need to turn it into a decimal. So that's 0.02. Remember, divide by 100 to get rid of the percent sign. And then, or move it 2 decimal places. Kim, I see your message. I'll come back to you in a second. I know how to fix that. So now to solve this, it's just substituting into this equation, right? So the key here is 2001 to 2021, right? That is a difference of 20 years, right? Just like we did before, take 2021 minus 2000 gives me, minus 2001 gives me 20. So let me write it here. We know we want our X to equal 20, and we found that by doing 2021 minus 2001. So now we just put this into our lovely formula. So A is 2000, parentheses 1 plus 0.02, so 0.02 raised to the 20th power. So I go to my calculator, clear, 2000 times parentheses 1 plus 0.02, close parentheses, raised to the 20th power. And I get 2971.89. And again, we round to the nearest person. So 2,972. So in 20 years, if our population follows this exponential growth, we will gain basically 972 people according to this formula if it continues down this path. All right, so just to recap, because there is a relationship between exponential and logarithmic, right? So remember, all exponential is y equals b to the x. Remember, x is the variable and it is the exponent. So something that makes an equation or an expression exponential, the variable is in the exponent. That's the only difference, right? Linear and the quadratic, the variable is the base. exponential, the variable is the exponent, right? And so when we go to logarithmic, as it slowly loads, it's kind of a way to bounce it back and forth. So these two functions are related. So if I have y equals b to the x as exponential, I can swap things around. Basically, notice the x and the y swap places. So I have y equals in the exponential, and in the logarithmic, I have x equals. So the way I do this is I can take the x and drop it down. So take the exponent and drop it down and make it equal. And what I do is I take the log of the base of the y value, right? And so this is where we got to be careful with our calculators. On your calculator, if you see the log key by itself, that is log to the base 10. So b is 10. We're lazy mathematicians. We don't write it. So, but trust me, it's there, right? So log all by itself on your calculator, right? So if you look at your calculator, you should have a key that just says, I'll try not to write cursive. I think it just says, oh, that's a horrible L, but just says this, log. What it is to the base 10. So even though your calculator doesn't show it, there is a 10 there, right? So you gotta be really careful. If you're doing problems and it is, say, the problem has log and it has a 2 here in the problem, log base 2, your calculator will not solve that problem. Now, if you have a TI-84, you can make it solve that problem. I'm going to show you ways to do it that you don't have to go buy an expensive calculator. Also, Excel will solve it for you. So again, we already know Excel is for free. So please don't go buy a special calculator because your calculator cannot do log anything besides log 10. All the problems we're going to do in this class are log 10. So you don't have to worry about it for this class anyway. But if you go into college algebra, math 122, that's when you'll do logs to the different bases. What we'll do in our class is we'll do some conversions, like moving things around, as well as using log to solve some formulas, right? And we do a couple examples of that here. And I think that's what I put in the chapter review for Hawks. And that's what you may see on the test is just using your log key. But I just want to make sure that's clear. Log by itself is base 10. So b is equal to 10. And so the features, the domain and the range all swap places because the x and y swap places. The domain and range also swap places. So I have all the rules listed out here again. And if we graph them, it looks very similar to the exponential. I'm not going to go through all that again. There's a lot of the theory. These things are basically the same. What it really comes down to is moving things around. And the point of these in algebra is to move things around so you can solve them by hand. Right now in technology, a lot of these things are not required and we don't do them in the real world as much anymore because there's no reason to because I have technology. Right. So that's why in my homework that I've tried to give is I've tried to give you examples where these functions are useful and you just have to be able to use your calculator to make analysis with them. Right. So not so much dissecting them, but understanding. Right. So if I want to move things around, if I have 25 equals 125 raised to the 2/3 power, right? So 25 equals, and again, the whole point of this problem is just to see how things move around and you get the same answer, right? So if you actually went to your calculator and you typed in 125 and you put the exponent to be 2/3, your calculator should, if you have a decent calculator, spit out the answer 25. Right, so if you type in your calculator 125 and either use the caret key and put in parentheses 2/3, or if you have an exponent key, put in the exponent. Right, if you type that into your calculator will tell you it is 25, right? But if I want to change this into log form, right, the way you change this into log form is you take the exponent and you move it over here. So now I get 2/3 equals, and I now put in the log, and then 125 becomes the base of my log, and I am going to take the log of the number. Oops, that's ugly. Clean my writing up here. Of 25. And you're probably asking yourself, why would I want to do that? And my answer would be, I totally agree, right? Because I just took a problem that was probably easy to solve and made it much harder. But if one of these pieces is missing, then it might be a good technique to solve the problem, right? So for the example I give, and we'll just clean this up because I have it all written out over here anyway. I just want to draw it as I say it, that way it makes sense. Say I have one that's in log form. So if I say -1 equals the log base 3 of 1/3, right? Again, you can't solve that. But if I turn it to exponential, which means this is my x, right? So he moves back over here. So I get 1/3 to the -1 power. And then remember, oh no, sorry. I messed that up. -1 on the base of 3. So it's 3 to the -1 equals, remember this, what's in parentheses is the y, equals 1/3. Now, if you go to your calculator and you do 3 to the -1 power, your calculator should give you 1/3. Some calculators are picky. They don't like the negative exponent. So you got to remember your rules of algebra. Negative exponents mean you just flip things. So my 3 becomes 1/3. Again, don't stress over this. We're talking theory just so we understand what it is. All right. It's just the foundation. What I want you to be able to do is solve problems with this. So we're going to get to that in a minute, but I'm trying to just show the relationship between these two things. This is again, for anyone that's going to move on to algebra, they need this piece before they get to algebra. Where I think this comes useful is again, when you have to solve for something that's missing. So say if you have a function that x equals log 2 to the y, and I tell you x equals 8. So then I put 8 in for x, right? So I get 8 equals log 2y, right? The way that is currently written, I can't solve for that, right? Because y is over here with this log thing. Unless I want to sit there and just keep randomly throwing numbers at my calculator until I get the answer of 8, right? Guess and check, which is a method, not recommended, but it is a method. The better thing to do here is understanding the relationship between a logarithmic and an exponential, that I can rewrite this. So if I put this into exponent form, 2 is my base, right? So remember, this is my x. So it comes over here and joins the 2. So this becomes 2 to the 8th power equals y. And now I can go to my calculator and do 2, raise it to the 8th power, and I get the answer of 256. So I took a problem that was more challenging to solve, rearranged it into a function that I could actually solve, and got the answer. That's the power of these two, understanding the relationship between an exponential and a logarithmic. And vice versa, if I know y equals 64, right, then I get x equals log 2 of 64. So if my calculator can do log 2, then I can just solve this problem. I could rewrite it and figure out 2 to what power gives me 64. But another option is we bring our friend in of Excel, right? And so if you go to Excel, I type in equals, and I can type in log, and you can see it has log 10, which is exactly what your calculator does, or I can click on log. And what you do here is it wants the log of the number you're taking. And so in this case, the number is 64. Then it asks you, well, what is the base? and it's base 2. So I put a 2 in and I get the answer of 6. So again, do not go buy a fancy calculator. You can just use Excel if you had to solve a weird log problem. But if I rewrite this using exponential, trying to bring this over so you can see both. There we go. Right, so if I move things around, so again, this is my base 2. X is my exponent, so it comes 2 to the x equals 64. I know by using Excel, the answer is 6, right? But if I put 2 to the 6th power, I also get 64. So that is how these two functions are related, exponential and logarithmic, right? And that's where it really comes into advanced algebra. And if you take pre-calc, college algebra, and go into calculus, then you spend a lot of time manipulating these things. For us, what I like to understand is there is lots of formulas out there that use these concepts, right? And so that is where I like to take this. There is a special logarithmic, before we get into formulas, I just look at my notes, where we have, it's called the natural log, which on your calculator, I'm looking at mine because I always write it half cursive and half print, which throws off some people. Yeah, it's just LN, right? Which looks like a capital I, but it's LN. That stands for natural log. And that is to the base E. And last class, we talked about how to find E, right? 2.71828. So E and natural log are related. And so that is just another key on the junior calculator. So when we're talking base 10, that is our lovely friend up here, log. If I am talking natural log, I am dealing with our lovely friend back to the E. And so ln of x just equals log to the base E. It's just instead of writing log to the base E, a function was created called natural log. And again, if you take advanced algebra, you can play around and get deep understanding for that. But for us, just know there's a cool guy called the natural log, and that's the difference on your calculator. Natural log deals with E, log deals with base 10. And so I think what's important here is understanding where you may see these things. So some cool things that are in the book. Earthquakes, right? The Richter scale is based on log, right? So when they predict the intensity of an earthquake, but using the Richter scale, the formula is log. So there's where some logs applied in the real world. Sound waves are, and sound intensity are also log functions. So there's a lot of things in science that are up to the base log. Till I taught this class, I didn't know human memory is also based to the log. It's actually based on natural log, which I thought was interesting. Again, medical, not to offend any of my nurses, since I have so many of you in my class, medical has just not been something that's been a big interest to me. So I learned that when I taught this class, the human memory capacity is actually a natural log function. And it gives you into the book. So a lot of the homework problems, it is just substituting numbers in the right place. What is confusing, and I want to make sure I cover this before we do a problem. Notice in the earthquake scale and the sound intensity formula, it has I as intensity over IO, which is the starting threshold, right? For all of our problems, we're going to assume the starting threshold to always be the number 1, right? So any whole problem that says, hey, we're going to start at the basic threshold, IO is 1. So that whole fraction just goes away because you can put any number over 1, right? So until I went and did some of the homework problems, I didn't realize it. I kept reading the problems like, well, where is my starting point? And then I had to go back and read the book. And it says in very fine print, that the threshold is considered a starting intensity of the value 1. So all of those fractions just end up going away. So keep that in mind when you go solve the problems, that IO just equals 1, unless it tells you differently. And I didn't give you any problems where it doesn't tell you it differently. So just remember it equals 1. And a lot of these problems, all it's going to have you do is just again, just substituting numbers into the formula. And just really what it comes down to is being very careful with your calculator, right? And what's challenging is, even though I recommended certain calculators, everyone's calculator is a little different. So you really got to get comfortable with your calculator and how to put these things in, and then make notes, right? So I was working with a couple students yesterday. Their calculators needed parentheses in a certain space. Others didn't need the parentheses in a certain space. So knowing the quirks of your calculator. I know one of you has the wonderful calculator. You have to do everything backwards, right? So knowing that how your calculator works for these, I think is important. I think a lot of you are frustrated with the algebra when it may just be your calculator makes the problem way harder than it needs to be, right? And that's why I was working with a student yesterday, and I said, look, I do everything in Excel because I can see what I'm doing, and then it's easy for me to fix things when they don't work. Again, Excel is not required, but I think it really is for chapter 5 is just getting comfortable with your calculator and how it works. And this is extremely important moving forward, because probability and statistics, the math in probability and statistics, the arithmetic in probability statistics is not hard. What's hard is there is special formulas for a lot of different concepts. And so again, it is how do you put this into the calculator correctly so that your calculator knows what you want it to do, right? So again, chapter 7 and 8 is going to come down to, again, putting things in your calculator the correct way. Chapter 9, finance. First part of the finance lessons, pretty straightforward. The last couple sections of the finance, pretty straightforward, but the formulas become pretty ugly. And again, it comes down to putting it into your calculator the right way, right? And if you look at my YouTube videos, I think the chapter 9 video, homework video is the longest of them all because it takes me that long to put the numbers into the calculator, right? So it's, again, practice with your calculator. So if you don't have one by now, please get one. Stop using your cell phone because these formulas are just going to get uglier and uglier, and your cell phone is just going to frustrate you more and more. If you don't have the money, then definitely start using Excel to do your calculations because it's just going to make your life a lot easier in the end. And I told one student, if you are using Excel like I am, and you start creating the formulas and saving them in that Excel, you can use that Excel on the test. You can pre-create the Excel to do what you want it to do and save it. And just call it your QRXL calculator if you want, right? And so what she did is she created a formula for the quadratic and saved her Excel, hopefully. And now every time she has a quadratic problem, she can just open that Excel file up and put in the values and it just solves it for her. I am completely fine to me. That is not cheating. That is using technology to do the arithmetic and you understanding the concepts. That's the key to these, I think. So I kind of show you some examples. So a big one, I think this is one of the homework problems too. So a cat per is 316 times as intense as the threshold, right? How many decibels, so that is dB, is a cat per, right? Round to the nearest whole decibel. So it gives you the formula here, right? And you'll notice in the videos for these homeworks, I have the OneNote open almost the entire time. So I would definitely do that because a lot of it's just from formula. So I'm just using this formula. So in my calculator, I'm going to do 10 times log, and this is to the base 10, so you just have to use your log key. Intensity is 316. And again, because it says as a threshold, it is just over 1, but any number over 1 is just itself. So in your calculator, or I'm going to use Excel, I'm just going to do 10 times the log, log, and it's log base 10. So I'm just going to click on the log 10 one of 316. No, I didn't put my parentheses in. So I get the answer of 24.99. So if you did this in your calculator, I'll do it in my calculator, make sure my calculator works too. So let's say clear 10 times, where's my log key? There you are. Log of 316. Same answer, 24.99. And it says round to the nearest decibel. So the answer is 25. So the decibels of a cat per is 25. Now, what all that means, it's just the sound intensity of a ratio. So basically how loud of a cat per is. So what is 25? I don't know because I don't know the science between sound, because again, it's not something of my expertise, but that's what these formulas do. And I think this is where most of you will do this kind of analysis in the real world, right? You're not going to create formulas, right? Whatever field you're studying is going to have formulas that you need to use to solve for things, right? And it's just putting things into your calculator. So if you have some formula that uses logarithmic, understanding what log is. If you have some formula that has an exponential in it, understanding what an exponential is versus quadratic or linear, right? Every field has a set of formulas that they need to use, right? So, I think the ones that jump out to me from my nursing students is our lovely class dosage calc, which is all kinds of different formulas of how to go from syringes to this, to that, right? Because I've tutored it. I'm not a great tutor at it, but some of my nurses just like my style, so we fight through it together. It's just using the right formulas, right? Engineers, you have a set of formulas. Finance has a set of formulas. Human services has a set of formulas. Everybody has a set of formulas. And so that's what this section, I think the big takeaway that I would like you to take from this is understanding how you use these different formulas to do calculations and the power of them. So there's not a lot of algebra per se of moving things around. There's a few problems, right? That I give you where you have to move some things around, but most of the problems is just substituting the numbers into the formula in the right place, making sure your calculator can do the calculations that are required, and